Hi everyone, welcome back to Workshop, and today I've got the repair of a Druck loop calibrator. This is a 4 to 20 milliamp loop calibrator. These are generally used in industrial applications, for instance offshore or any kind of large plant, that sort of thing. Maybe where you've got lots of pressure transmitters or sensors, as some people call them, or flow transmitters, that sort of thing, and you might want to simulate the actual transmitter into the PLC, the programmable logic controller input, and simulate the output from the transmitter. These transmitters, etc., generally work across the range of 4 to 20 milliamps, and therefore this device here can simulate the transmitter. So this particular has a couple of different modes. It has a read function whereby, as you can see from this here, you've got an existing transmitter. This looks like a pressure transmitter or something like that, and you've got the actual PLC system here, which produces a generally like a 24 volt output that goes down through the transmitter and then generally back to the system again, and that's your 4 to 20 milliamp loop that's being regulated by the transmitter depending on the pressure that's been applied to it. So you can stick the 4 to 20 milliamp Druck in series with that loop. Generally you can stick it anywhere in series with the loop because the current's going to be the same at any particular part of it, and you can read the existing 4 to 20 milliamp current in the loop at any time. So apply pressure and you'll see it come up on the LCD there. And for transmitter simulation, where you might want to attach the device directly to the system to simulate the 4 to 20 milliamp range into the PLC system, you can hook it up like this here. And you've got a couple of buttons on the unit here to step up and down through the 4 to 20 milliamp range going into the PLC system there. So the switch at the top here, obviously off in the middle, and you can put it into read mode to the right, or the 4 to 20 milliamp simulation mode to the left hand side there. And what this switch does is allow you to decide whether you want the loop power to be generated from the calibrator itself or from an external source. And you've basically just got an external or internal switch there. So if you've got it on the internal mode there, then your source for your 4 to 20 milliamp loop will be output on the red wire here, and it'll be looking for it to come back on the black wire there. If you put it to the external side, then generally you will have a separate 24 volt power supply, something like that, that's generating or can generate the current, and this unit here in series with that loop will attenuate that current in the range of 4 to 20 milliamps. So this unit's faulty. It says that it has no output, but I also noticed that there looks to be something possibly wrong with the LCD, apart from the cover, the label here. Basically the screen here looks to have lifted, but there does look to be some kind of artifact down inside the LCD there, so I'm not sure if that's dirt or something, or whether it's the LCD itself that's broken. So we'll open the unit up and we'll take a look inside and we'll see if we can repair it. This unit was supplied by RS Components. It's actually got a label on the bottom there. RS Components 182-5456. And I've already looked that up, and they retailed for just over £500 for this unit here, including VAT. So they were quite expensive back in the day. And you can see there's space for 4 AA batteries there. You've got a DC input here if you want to use it, a small choke, and the circuit board itself. So let's see how we can get that circuit board off. Does it lift out? No, it looks to be in pretty... Oh, there we go. Aha. Okay. The top board here just unplugs. You've got a couple of... Well, you've got 3 connectors there that just simply unplugged. So, yeah. And then this here that's screwed in, so we'll get that one out as well. Just want to take a look at the electronics before I actually power it up and see what happens. But okay, oh, it's in pretty tight. Okay, it's not screwed in, it's just the wires. There's a couple of grommets on the top there, and the wires are obviously just tight on the inside, so I'm having to sort of feed them through, and the grommets are pretty tight there in order to try and get some length on the inside, which I'm just about managing to do. Before I go any further, I think I'll see if I can remove I don't think this DC input's ever been used. That looks like it's been in there a while. Those grommets are in there pretty solid. I think I'll put a bit of grease on that wires there and it'll help push them through the grommet. There we go, that's a lot better. If I can just get some length on the red one, then I can flip the board. That's the plan anyway. And there we go. So there's both the boards. So looking at the LCD there, that is within the glass there. That is not on the surface of the glass there. So it looks like I'll need to try and get a hold of another LCD. Not sure if this is a standard LCD or if this is something custom. Looking at the manual here, it just looks like it's a 5-digit display. Not sure if there's any screenshots anywhere in the manual. Yeah, it looks like it could be something custom because there is some indicators on the display itself, so I'm probably not going to be able to replace the LCD, so let's just hope it's working. Everything else looks okay, there doesn't look to be any other kind of damage. So I think I'll pop in some batteries and power it up and see if we're getting an output. Okay, we're all ready to give it a go now. I've got the source switch in the internal position so that this device here is going to source the power for the loop, and I've got the two wires connected directly across my multimeter here in milliamps mode. You can't really short circuit the loop. This unit here is going to regulate the output current from to within the 4 to 20 milliamp range. There is a maximum resistance for the loop. For the minimum, you can just directly connect this output here directly across your milliamp meter there. So we're all ready to go, so let's switch it on. And immediately I've got 4 milliamps on the display there. And look, I've got 4 milliamps on the multimeter as well. This does look like it's working. Okay, so let's see if I can use the up down buttons to change the current, and it is changing. Can I hold it? Yeah, it's going up faster. So I've set it now to 4.65, 4.64, that's good enough. Now I should be able to put this unit into a different mode. Fixed steps. And what that allows me to do is to go up in 4 milliamp steps. So we start at the bottom at 4 milliamps, then I've got 8 milliamps. That's designed in to give you a 0%, a 25%, a 50%, 75% and 100%. So 8 milliamps being 25% and 12 milliamps is your 50%, so that's your reading there, all the way up to 20 milliamps. That's working. Now that's curious. Well, the ad did say that the unit had no output. So there's a couple of reasons for that. It could be that the person that was testing it didn't know what they were doing and didn't realise the functionality of the internal external switch here. Because if I now go and put that in the external position, I will get no output, and in fact it's flashing loop on the display here to tell me that there's a problem with the loop. And that's the reason that 4 to 20 milliamp signals are used widely in industrial applications, because 4 milliamps is like your zero. Anything less than that, then it's basically the PLC or the programmable logic controller will know that there's something wrong with that signal, that somewhere externally there's a problem, like an open circuit, something like that. Yeah, so back to 20 milliamps and it's perfect. The other thing it could be is that these two boards here did seem to come apart pretty easily, so it's possible there's a dodgy contact or it just wasn't connected properly, but I mean it was screwed together and the screws were tight, so not really sure about that. It's not the choke or anything like that. Possibly there's a dry joint, but I'll go over them. But that's working. Okay, I think now we'll try the unit in the external position, i.e. we'll hook up a power supply, a 24 volt power supply, and use that to power the 4 to 20 milliamp loop. So let me go and hook that up now. So I've got 24 volts on the end of these bananas here, straight from my power supply. So we're going to put the positive direct to the positive input on the multimeter. That'll kick off the loop. Then the common out of the common out of the multimeter will then go to the positive on the calibrator, and the black wire, the negative on the calibrator, will then go to ground in the power supply, or 0 volts. I'm going to switch on the power supply, and straight away 20 milliamps, we've got 20 milliamps there, and it should go down to 4 milliamps as well. That's working. The only other mode still to test would be the read mode, where I've got an existing 4 to 20 milliamp loop and I'll put this unit in series with it, and we should see a readout here of the current in milliamps in the loop. So let me go and hook that up now. Okay, so what I've got is my 24 volts from my external power supply coming into one of Jerry Sweeney's decade boxes here. I've got that set to 2K, and out through there, through the milliamp meter, and then through the Druck, and then back to 0 volts on the power supply. And I'm going to put the switch in the read position. So the power supply is on at the moment, so if I go over to read, there we go, just under 12 milliamps. I've got a 2K resistor here, and I'm externally feeding 24 volts, so the read is working. And if I pull the resistor here, 0 milliamps there, because I've basically open circuited the decade box. I should be able to go to 3K, and then we're down at 7.86. That's working. So as far as I can see, this unit's working. Okay, so let me clear the bench and we'll take another look at the PCBs again then. Let's go over some of the components on the two PCBs, starting with this one here. This is an MC14433P. This is actually a 3.5 digit LCD driver with built-in A to D. Now in this particular case, I don't think it's actually driving the LCD directly itself, which it's capable of doing. That's why it's got so many pins on it. It's quite common back in the day to just use maybe part of the circuit, the A to D part, and not bother with the 3.5 digit LCD driver. And I think that's the case in here, because the LCD itself is actually interfaced to this TMP47P421 ADF, and that's actually a 4-bit microcontroller, but you can see with the number of pins on it, it's got more than the capability required to drive the LCD itself. So I think that's what's happening there. So you know, this is just using this as an A to D only. We've got an op-amp here, LT1077. We've got a DAC1232, that's a 12-bit D to A converter. Another LT1077, and then we've got a large N-channel FET there. We've got an LM317 over here, that'll be for the power supply side, and a 7660, that's a very, very common charge pump IC. So that'll be, this section here will be boosting up the batteries to the required 24-25 volts open loop power requirement for the 420 milliamp loop. And you've just got a bunch of supporting ICs there. Obviously got some pots there for possibly calibrating the 420 milliamps. I'm not too sure about that. I don't have a schematic for this device here. Over on this main board here, we've got the LCD itself, like I said, the microcontroller there, and we've got this IC here, which is a I can't quite read the number on that. That's a 34063 AP1. That is a reference, a voltage reference and control circuit for a DC to DC converter. So whether that's got something to do with the power supply side, I'm not too sure. Like I said, I don't have a schematic for the unit there. And obviously the 4 push buttons there are interfaced directly to the microcontroller there. And we've got a, presume that's such a BC155, that's just a transistor I think there. So looking at the boards, actually they're in very, very good shape. I can't see any dry joints. All the joints are nice and shiny. There's no signs of any leaking caps or anything like that. I wouldn't expect that in something of this low power requirement. It's not going to generate much heat at all, if any. And the connectors here, I mean, don't look as if they're oxidized very much at all. Maybe very, very slightly, but not enough that I think that would cause a problem to make the unit stop working. And on this board here, it's basically the same state. It does look to be in very good condition. And there's underside there with the 3 connectors. I thought for a start that there was some, possibly this here looked like it maybe heated up, but it's not. It's just the flux that's been used to solder on the external wires there. So I don't think there's any problem there at all. There's nothing worth resoldering, everything looks perfect. And I mean, the wires here were very tight in the grommets, so it's not like they were pulled at all and, you know, maybe broken or something like that. Oh, this one here's got a little bit of a kink in it. I wonder if that's a problem there. You see that there? It's possible that's a problem, but no, that's solid. If I'm pulling it there, it's not stretching in the slightest, so I think it's just a kink in the silicon of the actual wire itself. The black wire is probably the same. Yes, it is. Yeah, there's no broken wires there. The other thing it could be is maybe dirt or oxidization inside the switches itself. This one middle, this top one here, the on-off switch and read switch, does look like it's pretty dry. It looks like it's very dry, so I think maybe what I'll do there is squeeze in, squirt in some contact cleaner. This switch here is actually an open switch here. You can actually see down inside it there, whereas the other switch looks like it's totally sealed. So yeah, I think I'll put some contact cleaner on that switch there and see if I can help it on its way. So the only other problem I've got, which is a little bit of a shame, is the actual LCD. With this squiggle is what I would like to call it, which is not within the liquid crystal layer, but looks like it's just on one of the top layers below this first level of protective glass on the top of the LCD there. It looks like it's on the underside of that. It's certainly not on the outside. and there's not really much I can do about that. The only thing I could possibly do is replace the LCD, but I don't know if it's worth it. I mean, I'm not planning on selling this unit, even though it's valued at brand new at £500. I've got an up and coming project which I'd like to use a 42 milliamp calibrator, so I think I'll just keep a hold of this unit. Well, let's put it back together and let's see if it's still working. So I was just putting the unit back together and I just realised that indeed this top board's not screwed in, it's this bottom board that's screwed to the case. This top board just plugs in and that's basically it. And the rear of the case has got these two strips here that are obviously used to press down against the batteries to hold them in place, you know, like that there. And there's nothing really to stop this board from actually popping up. But when I did take it off, I mean, it did unplug, if you know what I mean. It didn't immediately look like it was sitting unplugged or anything like that. So I'm not really sure what's going on there. So I'll just plug it back together again. And that's it back together again. I think there's maybe something missing from here, some kind of neoprene foam padding there to push down on the back of the board. That's what I would have thought there would have been. Because I think that could pop up. But it's back together again anyway. Well, that's it back together again, so I'll just check and see if it's working. Out, internal, and I'll just short out the red and black. And immediately we've got 4 milliamps on the display. It's a shame about this front screen here. It's in a real state. I'm almost tempted to just pull it away. But I mean, it's basically a big hole straight through to the LCD, but you can hardly read the display because it's so manky, this front screen. So maybe I can replace it with something, I'm not sure. I think somebody's already had a go at super gluing this two corners down here, because there is some glue residue there and there, so somebody's already had a bash at that. So, but I mean, it is working. Certainly not getting any open loop on there, all the way up to 20 milliamps as you can see. Thanks for watching.